Hey everybody, today's lesson is on geometric series. So last week we did arithmetic sequences. After that we did arithmetic series. Remember that the series is when you add up the terms of the sequence. So this is geometric series, so we're going to be adding up the terms of a geometric sequence. All right, so let's 3 examples today. We're going to be using these formulas, so we know that this is the formula for the nth term, right? This helps you write the sequence out, a1 times r to the n minus 1. So now to find the sum of a sequence, it's going to be the first term, a1, times 1 minus r to the n divided by 1 minus r. All right, so the 3 things that we need in order to find the sum of a geometric series is the first term, the common ratio, and n, which is how many numbers we're actually adding together. So let's do number 1. Number 1, again, we have this notation. Don't get fooled by the notation. This is just the Greek symbol for sum. So we're finding the sum of terms 1 to 10. So we're adding 10 terms together, and this is the formula for the sequence. So that means 5 is the first term, and the common ratio is 2. And we're adding 10 terms together. So we know that the first term is 5, we know that the common ratio is 2, and we know that we are adding 10 terms together. So we're just going to plug in those 3 variables into our sum formula up here. So the sum of the 10 terms, we're adding 10 terms together, is going to be a1, which is 5, times 1 minus 2 to the 10th power, all divided by 1 minus 2. All right? So the hardest part is actually plugging this into the calculator correctly, right? So we're going to do 1 minus 2 to the 10th divided by, the denominator here is going to be negative 1. 1 minus 2 is negative 1. We're going to do this, and then we're going to multiply by 5. And I want these answers, if you could, to leave them in fraction form, or if it's a decimal that terminates, that stops, you can leave it in decimal form. But if it's a repeating decimal, I want it in fraction form. So let's go ahead and enter this into the calculator. So my numerator is going to be 1 minus 2 to the 10th power, and then I'm going to divide by negative 1, because my denominator is negative 1, and then I'm going to multiply by 5, and that's going to give me 5,115. So S10 here is going to be 5,115. That's the sum of the first 10 terms of this geometric sequence. All right, let's do number 2 now. So we're adding 6 numbers together. N is 6. The first term is going to be 4, and the common ratio is going to be 1/4. So plugging into the formula, the sum of the 6 terms is going to be the first term, which is 4, times 1 minus r, which is 1/4, to the 6th power, divided by 1 minus 1/4. All right. 1 minus 1/4 is 3/4. So I know my denominator is going to be 3/4. Now I just have to, I'm going to do this numerator, 1 minus 1/4 to the 6th. Remember, we're going to do 1/4 to the 6th, and then 1 minus that, divided by 3/4, and then times 4. So I'm going to put that all into the calculator. 1 minus 1/4 to the 6th power, divided by 3/4, and times 4. So I got a decimal that does not stop, so I'm going to make sure that this is in fraction form. And as a fraction, I get 1365 over 256, which is approximately 5.33, but I want the exact answer. I want the exact answer here. All right, number 3 now, I'm finding the sum of a infinite series now. This is an infinite series. So the first two, I'm adding a certain number of terms together. Number 1, I'm adding 10 terms. Number 2, I'm adding 6 terms. But number 3, this is an infinite series from 1 to infinity. There's a separate formula for an infinite series, much easier formula. So if the series is infinite, we're going to use this formula. It's simply a1 divided by 1 minus r, but notice it says that r must be less than 1. If r is not less than 1, then you actually cannot find the sum of an infinite series. You would actually say that there is no sum if the r is greater than 1. R has to be less than 1 in order to find the sum. So let's see here. I know that a1 is 2 and r is 1/6. So this r is less than 1, so I can find the sum. So the sum of this series is going to be the first term, 2, divided by 1 minus 1/6. 1 minus 1/6 is 5/6. So 2 divided by 5/6 is 2.4. And that decimal stops, so I can leave that as my answer, 2.4. 2.4 as a fraction is 12 over 5. So you can actually put the fraction, or this decimal is fine because the decimal stops. It's a terminating decimal, 2.4. All right, so again, if it's an infinite series, here's my formula here, but r has to be less than 1. If r was greater than 1, the answer would there actually is no answer. You would just write there no sum. You actually can't add an infinite sum together, or an infinite geometric series together, if the r is greater than 1, because the numbers keep getting larger and larger. When the r is less than 1, that means the numbers actually get smaller and smaller, and you can actually add them together, because eventually the sum, the sequence gets to 0, so you can actually add the numbers together. All right, so that is geometric series, adding the terms of a geometric sequence together.